Hello, myself B. Raju, working as an assistant professor in the Department of Artificial Intelligence and Data Science, Annamacharya University, Rajampet. Today, let me discuss about what is a classification and regression and machine learning model. Right. This is the representation about the classification regression. And let us talk about definition of classification. It is one of the machine learning which classifies the problem for identifying the set of categories as observations or the basis of any training data sets called as instances or observations, which has its membership. Here, when coming to the training data set, this training data sets will be considered as a labeled data sets or unlabeled data sets, and both we can have here. If the labeled data sets, which is known as a, a classifications either of observations and or instances, that will be considered as a training data sets, and which is not to be trained, that means unlabeled data sets, that is not to be considered as a training data sets. And we name this training data sets as a labeled data sets, and untraining data sets, unlabeled data sets, as supervised and unsupervised learning models. Let us have the table of the student analysis about the mark scores based on the results. And score 1 will have the results like this, and score 2 will have results like this, and the result will be considered as the pass or fail. Let us have the classification. From the above table, we had a training set of data with two attributes. One is score 1 and score 2, and these attributes will follows a class label which is of result, and the class label has two possible values, that is a pass and fail. And here we are going to have our categorical of data which has two categories or classes, and the set of data which the class label is pass and the set of data for which the class label is a fail. And let us have some knowledge representation for this by considering the unknown scores from the following table. And these are the scores I quoted, that these scores are not available in the following table, and just I am applying my knowledge for these two scores, score 1 for 25 and score 2 for 36, and the value should be matched with the result, and you will have a corresponding new data for the following two scores, and such kind of data will be compared as a category or classes for an observation. Next, sorry. Let us have the figuring. This figuring will identify the graphical representation of the problem what we have stated from the following table of past, and here I quoted the graphical representation of the data uh, with the following of x and y axis, and x axis will be called as a score 1 and y axis will be called as a score 2, and the solid data is identified with a pass class, and hollow data are identified as the fail class. Here the class labels are to be considered as a square dot, which is to be determined by uh, this pictorial forms. You can have an assumption of pictorial forms here, and the question mark what here applied is the identification of data. And let us have real-time examples of machine learning. Machine learning will have so many real-time examples. One among that one is optical character recognition. This is the problem which is going to be recognized by the character codes from the images, and we can have the best classification as a optical character recognition, that is OCR recognition. Next one is face recognition. Face recognition is one of the best input for an image for a group of people in a crowd source while passing in a society, and we can identify such kind of people in an associated wing with a particular facial expression recognition as a face image, and we can have such identities here. This is one of the best application in machine learning which will be used for more cases. Next, speech recognition. Speech recognition is one of the best input which is to be sophisticated for so many classes words that will be occurred. Next, come to the point of medical diagnosis. Medical diagnosis, here we can have some inputs related to the patient and their classes, whether the patient is active or inactive, and the inputs is based on the patient activeness, and the patient will have his age, gender, past medical history, and current symptoms. It will diagnose, the ML will diagnose the state of the nature of the person, whether he is active or inactive. This is the one. This is also one of the major application in ML. Next one is knowledge extraction. When coming to the point of knowledge extraction, we can have so many classification rules like association rule mining, and we had one concept called as KDD process in mining, that is knowledge discover data process. There we can extract the data, and such type of data will be framed by the rule based things. Next application is compression. Compression is one of the classification which is used as a simpler frame of data which requires less memory to store, and we can have the less computation also. Next, discriminant. Discriminant will vary the rule or function of a particular classification that should be assigned by labels or new observations. Let us consider one example, that the classification based on the conditions, like first condition I am applying here is if score 1 plus score 2 is greater than equal to 60, then we can have a pass, else fail. If score 1 is greater than equal to 20 and score 2 is greater than equal to 40, uh, then we can have a pass, we can have pass, else fail. Similar like that, this course has been designed for all the cases. Next, some of the algorithms which applied for classification, as well known that those are the algorithms listed here. One is logistic regression, naive Bayes classifier, KNN algorithm to be called as K nearest neighboring algorithm, a decision tree algorithm. In decision tree, the most important is ID3 algorithm, that is iterative Dicomester 3 algorithm, which identifies a particular class in a group. This is one of the best algorithm for decision making, whether it is a true or false. Next, support vector mission is one of the supervised learning. These are all comes under the supervised learning algorithms only. Support vector mission, we can identify in a group of a particular images whether two different images can be considered in this support vector mission. Next, random forest algorithm. So these are the algorithms identified in classification. Next, coming to the point of regression. Regression is meant for predicting the value that will be considered as a numeric value based on the observations of the variable. And here the value of the output variable may be a number such as an integer or floating value. These are all often quantities such as amounts, huge amounts of sizes and spaces. And here we can have the input variables like discrete or random. Next follows for some classification table, regression table, which is identified as data followed by the prices of the car. Next, let's talk about the general approach. This general approach is meant for the identifying the variables which is of input variables and output variables. Here I am going to code the variables as x and y in machine learning. The basic representation of this regression is a kind of mathematical which follows the relationship of x and y with the functionality which involves some parameters like y equal to f of x comma theta. So this f of x comma theta is a function called as a regression function which is used for machine learning algorithm that optimize the more number of errors which has been minimized, and we can use mean square errors for testing of hypothesis for this kind of general approach. We can have more number of training data sets for general approach. Let us take an example that a particular person as a input variable of his age, where he is travel, and what about the weight of a particular uh, person, and the what he expecting as a output variable like price, the model, and it will indicates the function like y equal to f of x comma theta. This is the rule that he quoted that we quoted for the function. Thus price equal to a0 plus a1 into age plus a2 into distance plus a3 of weight. That means here the age, distance, weight are three variables which comes under the variable, which these are the three uh, constraints which comes under the variable of x, where this will be treated as input and theta will be considered as the function of the function represents the theta which consists of a0, a1, a2, a3 like this. This is one of the parameter model. And identify a regression model. Some regression models are there: simple linear regression model, multivariate regression model, uh, logistic model. Likewise, there are various types of regressions available, which is meant for making of some predictions, and we can have three different aspects for regression variables like name, number, and type, which is of dependent and independent, and it will frame a shape of the line as a regression line like slope. Like for example, if I take a plane of x and y, uh, in between x and y we had a slope of the line that is y slope of the line y equal to mx plus c, and this slope of the line will vary at different variables in between x and y axis. Let us talk about simple linear regression models. Before a start of a talk related to regression models, let us discuss about what is meant by independent variable and dependent variable. We already discussed about variables in last slide, and here independent variable and dependent variable will be categorized based on the expression or an equation. Suppose if I have my uh, expression in simple linear regression, that is y equal to ax plus a plus bx. Here y is a dependent variable and a plus bx is a independent variables. This is the difference between dependent and independent variable. there is only one continuous independent variable x, and assume the relationship between independent variable and the dependent variable y. Whereas in multivariate linear regression, we can have more number of independent. That means independent variables will be increased in multivariate regression models. Let us have the equation y equal to a0 plus a1 x1 plus so on plus an xn, like this. Next, polynomial regression. Polynomial regression is a continuous independent variable which frames poly means many, that will be splitted in y equal to a0 plus a1 x plus so on an xn. Next is logistic regression. These are identified by the binary values zeros and ones, like its powers, like we can have probability of these zeros and ones into four components, and which will be equally distributed like 0 0 0 1 1 0 1 1, like this. So these are all about classification and regressions. Thank you. Meet in next session. Bye.